Hello folks, welcome to Engineering. In this tutorial we will make the flow simulation of this RC drone using Solidworks. I hope you will enjoy it, keep watching. So we have to open the assembly file as previously did in RC helicopter. Here we will make this RC drone flow simulation. First, there is no flow simulation wizard here, so we have to go to Solidworks add-ins and scroll it down and check this flow simulation. Check these boxes and click OK. Then the flow simulation layout will be displayed here in this tab. Just wait. Now we get this here. Now we have to add a new parts for the simulation around these blades, these 4 blades. So we have to insert 4 parts. Click on this empty space, go to insert component, new part, choose on this empty face, go to insert component, new part, choose this empty space. So I think okay, there are 3 new parts. Go to insert component, new parts. Here is the 4 parts, so choose those parts and for simplicity add to new folder. This will be rotation regions. Those will be the rotation region of these RC helicopter blades. So we have to edit this part here and choose the top plane and make it plain. Okay, let's see it with the front plane. I think the blade, it doesn't touch the blade, so it's fine. Then click OK. So choose this plane and go to sketch. We will add a circle on this blade, around this blade, hover around this circle, the edge of the circle, and go up to here. Then press S for this shortcut key. Then smart dimension, specify this diameter. The diameter 150 is enough. So go to features, extrude boss base. Then here we will extrude it 20mm to fully cover the blade. 20 is enough. Then click OK. So try to make this. It is very important. Again, similarly, first exit this edit parts, and we'll do the same for each other 4 parts. We will add a sketch. First we need to choose top plane and make a plane parallel to it, parallel to it and away 20mm from it. Then sketch, draw a circle from the center to the edge and specify this dimension 150. Feature extrude post base. Okay, now we made this plane, so go to sketch on this plane, circle, specify this diameter 150 and extrude it 20mm. Okay, that's it. We made these circular discs around these 4 blades of this quadcopter. So as you see here, we have to rebuild this and save these 4 components, save it internally. We don't need it to be external as a new parts. So as you see from the picture here, the blades of these RC helicopters are rotated counterclockwise, counterclockwise. This is in order to balance the RC drone. If the blade of this RC drone rotate in the same direction, let's say counterclockwise, then the whole RC drone will rotate counterclockwise. So this difference of rotation will help this RC helicopter to balance out this drone. So we have to choose flow simulation wizard. You can say any name here. Next, choose SI unit. Next, we have to know the external, since we do the external analysis. Exclude cavity and exclude internal space. Here we have considered rotation and gravity. Next, here we will add gas. As you know, air has humidity, so check these 2 boxes. Next, finish. Now this body is recognized. As you see, the computational domain is very large. We have to go ahead and shrink those. It may take large time to analyze the results. So choose this face and shrink this. Now we have need small computational domain to work with, then click OK. Here we have to specify the rotational regions. Insert rotational regions, specify this RPM 150 RPM for this blade. Click OK. Okay, we have to add another. Delete this. Now here we choose this 150 RPM. Now for this and this part, we'll make it opposites. For this, minus 150 RPM. Add another rotational regions, minus 150 RPM for this component. Click OK. Now rotation region is ready. Here we have to set a goal. Insert goal. Here we wanna know about the thrust force. This will be the force in y direction. Choose this and okay, let's see another, the velocity in the y direction, then click OK. Now the results are not loaded. Okay, here we don't have to see this computational domain, so hide this and also this discus. Okay, drag it down. Hide these components. So now it is net. Okay, now the results are not loaded, so go ahead and run this analysis. It may take a while, depend on your core. Okay, let's pause it. Now the results are solved and the solver finishes this. So now it is ready for simulation. Let's see the results. Here we can insert float trajectories around these blades. Let's say this will be lines with arrow, and the lines, the number of lines will be, let's say 700. And here we have to choose some components. Here we will choose this impeller blade one, this blade. Now these 4 blades are chosen. So okay, let's say pressure. As you see, it may take a while. Let's pause it and get back. So now the calculation is finished. The flow trajectory seems like this. As you see, the top of the blade, the top of this is blue. From the legend, the blue is the low pressure, and at the bottom of this RC helicopter is red. The red is the high pressure, so this difference of pressure will hover this RC helicopter around the air. That's why the lift force is generated. Let's go ahead and play this simulation. As you see, around the blade there is a vortices. This is stunning. Even if you can record this animation for the export, just hit the record. Now it is finished. Okay, let's see the results. Hide this simulation and okay, let's see surface plots. Insert surface plot. Okay, use all the face and choose isoline and vectors. Streamline doesn't work in my computer, so because I don't have good graphics card. Okay, we will analyze pressure here, then click OK. It may take a while. So now it is prepared. The surface plots. Now you can move the legend around the graphics area of the Solidworks. As you see, the bottom face of this RC drone is red, and from the legend the red part is very high pressure, and at the top it is very low pressure relative to the bottom. So this will generate a lift to hover this RC helicopter around the air. So with this stunning visualization, engineers can design a better drone without wasting any resources, just by modeling this in Solidworks. I hope this video is helpful. See you soon. Thanks for watching.